So we are now taking the session wherein we are discussing the relationship between zeros and the coefficient of a polynomial. How do we reach that? And before giving to the formula about the relation, I'll just write one example and show you how that is derived at. If this is suppose a polynomial given and we are supposed to find out the zeros of this polynomial, so I'll do the middle term splitting. So I think it is 8, 12. So it is 2 and 6 will give. So it's minus 6x minus 2x plus 6. If I take 2 common, I'm assuming you follow this without any difficulty. You've done this as well before. So what I'm getting is 2x minus 2. And then it is some x minus 3, and this can again be written as 2 taken common, x minus 1 and x minus 3. So the two of them which I'm getting is x equals 1 and x equals 3. These are the two zeros. Now what about the sum of zeros? Because we are now trying to read the relations. Sum of zeros will be 1 plus minus 3. That's giving, oh, this is 3, sorry, it's not minus 3, so it will be simply 1 plus 3, that's 4. And what's the product of the zeros? Product of the zeros becomes 1 into 3. That's again 3, sorry. Now how we get this 4? If you look at this question, it is minus of minus 8 by 2. So this is given by minus of b by 2. In this case, as because b was minus, so we have put it again minus of 8. On the other hand, this is 6 by 2, which is c by a. Sorry, this is not 2, I'll replace it with a here. So the sum of the products, that is, if I assume that, or we represent the zeros in terms of alpha and beta, so the sum of zeros can be alpha plus beta will be minus b by a, and alpha beta, that is the product of the zeros, will be c by a. Sorry. Now we will be taking up, or this can be written as this. What is b? B is actually coefficient of x, coefficient of x, and the one below this is a, so it is coefficient, the same thing, of x square. This c here stand for constant, and again a is the coefficient of x square. Based on this kind of understanding, we'll take up a few questions now, which talks about the relation. Okay, I'll just write down the question. It says find the sum and the product of zeros of the given polynomials. I'll write down the polynomial. I'm taking up one with a quadratic polynomial, and another I'll take up here as a cubic polynomial. The one which is quadratic polynomial says it is 3x squared minus 5x plus 6. Sorry, I'll write the second question later on. Okay, here we previously learned how to find this is in the format ax squared plus bx plus c. A is 3 or B is minus 5 and C is 6. So I'll write them as well. A is 3, B is minus 5 and C is 6. Now sum of the zeros I'm not writing, I'm simply writing it is alpha plus beta I'm representing. So it is minus B by A, it's minus of minus 5 by 3, that's giving us 5 by 3. On the other hand, alpha beta, that is the product of the zeros, is given by C, that's C by A, it is 6 by 3, that is 2. I now take up, this was a pretty simple one, I take up another question where it is represented as 2x cubed, so it is a cubic polynomial, minus 4x square plus 3x minus 8. Now if you compare, this is ax cubed plus bx square plus cx plus d. That means A is 2, B is minus 4 and C is 3 and D is, oh, this is 8, this is 8, sorry, this is 8. So again the sum of zeros, that is alpha plus beta plus gamma here, because you have 3 of them now in a cubic one. So alpha beta gamma will be minus B by A, so it is minus of minus 4 by A, so it is 4 by 2, that is 2. And alpha, this here is alpha, beta and gamma is given by minus D by A. This is a little different to the one which you learnt in the previous part. So it is minus 8 by 2, it's giving us minus of minus 8. Oh, D is minus 8, right? Minus of minus 8, so it is plus 4. So alpha beta gamma is plus 4. You need to just have a look at this question because it is different to the previous one. Thereby you remember you have 3 zeros in this cubic polynomial. Take up another question, maybe based but differently placed one. I take this as, okay, I write another one. It says find the, I'm just using a short form of quadratic polynomial whose, this is the other way around question, you have to find the quadratic polynomial whose zeros are given. Whose zeros are, the zeros are given as 3 plus root 5 by 2 and 3 minus root 5 by 2. Now if these are the zeros, I assume this to be alpha and beta, so sum of them will be alpha plus beta, which is 3 plus root 5 by 2 plus 3 minus root 5 by 2. If we solve, I think I'll get 3 plus root 5 plus 3 minus root 5 by 2, that's cancelling, so it is 6 upon 2, and that's giving us 3. Alpha beta, that is product of the two numbers, that 3 plus root 5 by 2 multiplied to 3 minus root 5 by 2, multiplying the numerator, it is 3 square minus root 5 square by 4. So it is 9 minus 5, 4 by 4 equals 1. Now to find the quadratic polynomial, remember it is x square plus, here it is x square minus sum into x plus the product of the zeros. Either you remember this or you have to find this is equal to b by a, this is equal to c by a. That means what? A is equal to c. Here it is a is equal to c and b is equal to 3a. So c by a is 1 and b equals to 3a. Either you continue this solving these two and find your b and a, or it is always preferable to remember this as x square minus sum of the zeros into x plus product of the zeros. So it is x square minus sum was found to be 3x, product was found to be 1, so it is x square minus 3x plus 1.